Okay, so today we are going to start section 5 of the prerequisite chapter, and we're going to cover rational expressions. Now, on this slide, it introduced what a domain is, and we're going to cover domain in more depth in chapter 2. But for right now, whenever you start to do any of these problems, you're always going to assume that the domain is all real numbers. The only time that we're going to see exceptions is if you have a fraction and there's a variable in the denominator. Then what we would have to do is try to figure out what numbers we would exclude that could possibly make that denominator a 0, because you never want a 0 in the bottom of your fraction. Then the other time that we would exclude numbers from the domain is when there's a variable under a square root, or a variable where there's a square root that's in the denominator. So again, we will go more in depth for domain in chapter 2, but just be aware that traditionally any number could be plugged in for x, because x's domain is always your x value. So let's get into what we're really going to do today, and we're going to simplify fractions. So a lot of things that I'm going to talk about today are going to be some common mistakes that I always see the first time students take a test on this or a quiz. I'm going to tell you what not to do because it happens every year. Just like that other common mistake I told you with the binomial squared that people did on the quiz, even though I told them not to do it, same thing's going to happen today. So this first example here, the 6/30, this is something that you probably learned how to do in 4th grade. So it's asking you to simplify this fraction, which is 6/30. In 4th grade, they probably told you find the GCF and divide by it. So I can do that. My GCF here is 6. So if I divide the numerator by 6, I get 1. If I divide the denominator by 6, I get 5. So this simplifies to 1/5. Now, what we're going to be doing with the more complicated problems, when we're simplifying rational expressions that have polynomials, we're going to be factoring. So if you prefer 6/30 and factor, do like a prime factorization of the 6 and the 30, make this 2 times 3, and make this 2 times 3 times 5, and then you look for things to simplify. Crosses off becomes 1s, and then now you're just left with 1/5. Again, I'm not going to expect you to do that when you're just simplifying a simple fraction like that. But when we have the trinomials, you will need to factor in order to simplify. Now, if your fraction includes variables and there's no addition or subtraction signs, I can also simplify the variables in the same way. So if I have an x in the top and an x in the bottom, remember x divided by x equals 1, so these both become 1s, and this will simplify to 3/y. So basically what I'm looking to do is find something in the numerator that is exactly in the denominator to simplify things. Pretty good? All right. So the next one, notice in my numerator I have x plus y, and in the denominator I have x plus y. Now, when I go to simplify these things, it doesn't mean that it becomes a 0. Just remember, anything divided by itself is a 1, so really these become 1s, and then my answer here is 2/5. On the next example, notice that even though this is backwards, this is still a positive y and a positive x. Remember, addition is commutative. So these two mean the same thing. So again, this would simplify, and this one would also simplify to 2/5. Now, the next one, however, notice this time both the x and the y's are the opposite signs. This will reduce. However, what I need to do is think about dividing out a GCF of -1 or So like, for example, if I take the denominator and I have y minus x, and I want to make it look like the top, I could divide out a GCF of -1, which would then make this, divide this by -1 and this by -1, and then I'm left with -y plus x, which then really turns into x minus y with a -1 in front. So I could actually turn the denominator into -1, x minus y. I still have the same top, and now I can simplify. And then I would get 1 over -1, which simplifies to -1. You should be able to, at some point, recognize this pattern, that x over y and y over x, this is going to be equivalent to -1. Because what I would do is change this to a 1, this to a -1, and it reduces to -1. We will use this quite often in our simplification process. The next one, notice the heading here, cannot be simplified. So notice the difference here. This has a plus sign. This does not in the denominator. What you need to think about is this fraction bar is like separating it into two groups. It's like a grouping symbol. So we have the denominator, that is x times y, and the numerator, that is 3x plus y. In order to get something to cancel, it needs to look identical. So here, I cannot cancel this x and this x, because in order to cancel the x from the top, I would have needed a 3 plus x in the bottom. Common mistakes on the test, students are going to think they can come here and cancel, and turn this into 3 over y. You cannot do that. In order to simplify, it has to be a perfect match. Look at the next one. Notice this one has a subtraction sign. This is an addition sign. I can't do the trick with the -1 here, because that trick only works when both the x and the y are opposite signs. Notice how these x's are the same. So I can't simplify anything here. If it asked you to simplify this, you would just rewrite it. Let's try some examples. So the first one is asking us to reduce 4 over 20. So I can do it the way that you've been doing it all along, divide them both by 4, and make it 1/5. You can also use the factoring. I could change the 20 into 4 times 5. In this case, I don't need to really go all the way to prime. I could cancel the 4s, and then again get 1/5 that way also. On number 2, when I go to simplify this, there is no plus or minus sign, so I can actually simplify the y and the y and be left with x over w. Now, if the question had x plus y over w plus y, this one could not be simplified because these are stuck together. And in order to simplify, you would look for an identical match. Over here, same idea. Now, some people on the quiz are going to say, oh, I can cross this off and my answer is 1. You cannot do that. Again, this fraction bar means that this x plus 1 is stuck together, and then this x is by itself. So in order to cancel, I would need another x plus 1 in the bottom to get it to simplify, or I would need another x in the top that's outside of the parentheses. Because remember, when it's being multiplied, you can simplify it. Like, for example, here it is with the x outside being multiplied. So this will simplify, and my final answer is x plus 1. Now, a few things that aren't in the slide, just to make you aware of, because you'll be using this a lot. For example, all right, so let's move on. When you have the same thing over the same thing, remember 5 divided by 5 doesn't become 0, it's a 1, because what we're doing is dividing. If I have an x plus 1 over an x plus 1, this is also going to simplify to a 1. Pretty good? All right, let's keep going. Then if I have x minus 1 over x minus 1, again, same thing over the same thing, and it's 1. What if I have x plus 1 and 1 plus x? Again, same thing. Remember, addition is commutative, so this also simplifies to a 1. The scenario when it equals -1 is when you have 1 minus x and then x minus 1. This is when we could divide out the -1 and make this -1, this +1, and when you have that set up, it's going to be equivalent to -1. You will use this a lot.
Can you scroll back to number 3 of the examples, please?
Okay, 3?
Yes.
I'm going to do 12 more examples. So again, simplify the hint, always factor first. So this one's pretty basic. You can factor it if you wish, or you could just say, well, I know 3/6 is 1/2, and then I can take away 1x out of the top and 1 out of the bottom, and my final answer here is 1 over 2x. If you prefer to factor it, the 3 times x would stay, and then the next one, I'd factor the 6 into 2 times 3, and the x squared into x times x, and then I would look for things to simplify. That would simplify, simplify, and now that leaves behind a 1 and 1 over 2x. Either way, that's how you can simplify. Now we're going to hit our first trinomial. So this is where factoring, you need to be fast. We will do this all throughout the year, so it'll be very beneficial if you're really good at finding the factors that'll produce the binomials. So really what I'm doing here is 2 different problems. I'm first going to factor the numerator. So I'm looking for the 2 binomials that when I FOIL them gives me that trinomial. So I'm looking for the 2 numbers that multiply to give me -12, but who add to give me +4. So those factors of -12 are going to be -2 and +6. So that's what I'm going to replace the numerator with. And now my denominator, it's not a trinomial. It's not the difference of 2 squares. All I can look at on this one is pulling out a GCF. So I'm going to divide them both by 3, and I'm left with x minus 2. And that's what I'll write in the denominator. Now I look for things to simplify. So I can simplify the x minus 2's, and now I'm left with x plus 6 over 3. Common mistake, students are going to try to simplify the 6 and the 3. You cannot do this. This is attached. This is your final answer. Do not divide the 6 by the 3. It needs to stay like that. Everybody good? Let's try the next one. Simple fraction. You can choose to factor it or just reduce. Let me rewrite the problem here. If you decide just to reduce the 18 over 60, I can divide them both by 6. This becomes a 3/10. And then I can also take care of the x's. Take out 2 x's out of this, leaves me 3 behind. If you want to factor the 18, 2 times 3 times 3, and x times x, and then the 60 would become 2 times 3 times, I need another 2. 2 times 2 times 3 times 5. X, 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 x. 15, 30, yep. So then now I'll look for things to simplify. A 2 and a 2, cross off, become 1s. And then 3, and then this, and this. And then now you'll multiply what remains. I have a 3 left on the top. And then I multiply 2 times 5, and then the 3 x's.
Miss Corey?
Yes.
On the bottom part, aren't you technically doing x to the second power minus x to the fifth power?
Exactly. So if I go ahead and subtract the exponents, I get x to the negative 3. And because I have a negative exponent, that tells me write it in the bottom. So that's another way that you can do it. Absolutely. Everybody good? So if you subtract your exponents on your variables, if you end up with a negative answer after you subtract, you write that variable in the denominator. If it's positive, it'll go to the numerator. Okay, let's try the next one. We're going to factor both the numerator and the denominator. So I need to factor the top trinomial. So I'm looking for two numbers that will multiply to give me negative 20, but who will add to give me positive 8. And those two factors are going to be negative 2 times positive 10. So x minus 2, x plus 10. And you should FOIL it. Once you think you found the factors, FOIL it. Make sure that it does work. And then the next one, two factors that will multiply to give me 10, but who add to give me 11. Don't forget about the obvious. It's going to be 1 times 10. And now we'll look for things to simplify. Becomes 1. And now my final answer is x minus 2 over x plus 1. I cannot cancel the x's because, again, remember, these are attached. Again, common mistakes. Students are going to come in here, think they can cross off the x's, but you cannot. You have to look for the identical binomial. Let's try number 9. The top, it's not a trinomial. I'm just going to factor out a GCF. So I can divide them both by 4. The denominator, I need to look for the factors of negative 18, that when I add them, give me negative 3. And that's going to be positive 3 times negative 6, because when I add them, it works. So x minus 6, x plus 3. And now I look for things to simplify. This cancels, and I'm left with 4 over x minus 6. I cannot reduce the 4 and the 6, because again, remember, this is attached. Number 10. I need to factor these two trinomials. Now, I can factor this top backwards the way it is. So I'm looking for factors of 12 that will give me negative 1. So I'll put my two x's here. I know the signs have to be different. So it's going to be 4 and 3. Whenever you try to get a 1 in the middle, That should be a clue that your two numbers are going to be side by side. Then for the denominator, you can either guess and test, or you can factor by grouping, and I'll show you both ways. If I guess and test, in my first spot here, I'm putting the factors of 2x squared. So I'll put a 2x and a 1x. Then in this spot, I'm putting the factors of the 4. So it's either going to be 1 and 4 or 2 and 2. So the factors that are actually going to work are going to be 1 and 4. And this one will be negative, negative, because it has to be a positive 4. Now, let's say you're not good at guessing and testing. Once you guess and test, you have to FOIL this. If after you FOIL it, if it doesn't go back to this, you've done something wrong. Let me show you the long way of what we've been doing. So you multiply the beginning and the end. Two numbers to multiply to give you 8x squared, but who also add to give you negative 9x. So again, those are going to be, we're adding to, so 1 and 8, and they're both negative. So rewrite the first term, replace the middle, and then rewrite the 4 on the end. Then factor by grouping. GCF here is x. GCF of blue, negative 4. And then the final answer, x minus 4, 2x minus 1, which is what I got when I guessed and tested. So now that I had the right thing in there, I'm going to look for things to cancel. Here's this case where we're going to use that negative 1 trick. So this would simplify to negative 1, this to a 1, and now I have negative 1 times 3 plus x over 2x minus 1, because these are gone. And now, instead of leaving it like that, I can just move the negative sign to the front and just do 3 plus x over 2x minus 1. If you want to just leave it right here in front, you can do that also. Let's try number 11.
Oh, wait, Miss Corey, can you stay there for a second?
Absolutely.
Thank you.
11 are two trinomials. Try number 11. So again, I need to factor the two trinomials. So for the numerator, you can either do the factor by grouping, or if you're good at guessing and testing, you could set it up. The factors of 3x squared are going to be 3x times 1x. And then what's nice about this is the factors of 2 are just 1 times 2. So you just have to decide, does the 2 go here and the 1 here, or vice versa? And then you also have to double check the sign. So I'm going to put a plus sign here and a minus here. And then I would FOIL it and double check that it did go back. And it does. For this one, I can do the same thing, because there's only one way to get a 5. It's 1 times 5. And only one way to get an x squared, it's x times x. So I'll put a 5 plus x and a 1 minus x. The signs have to be different. Now that I've done that, now I'll look for things to simplify. So again, these two are what will simplify. This becomes a 1. This becomes a negative 1. So now I'm left with 3x plus 2 over 5 plus x. And then the negative 1 I can put out front. Number 12, I only need to factor the numerator. I can pull out a GCF of 4. And again, be able to recognize that these will cancel, and this becomes a -1 and a +1. So now I'm left with 4 times -1 over 1, which is just -4. 4 more examples and we're done. So just lots of practice. Let's try number 13. I've got the difference of 2 squares. So I can factor this into x plus 5, x minus 5. I can't do anything with the denominator, so I'll just rewrite it. And now again, see how these look opposite? 1, -1. So now I'm left with x plus 5, and then I can move this negative in front. If you want to distribute it, you can, but you can leave it just like that. Number 14 is also a GCF. So from the numerator, I can factor out a 4x. And from the denominator, I can factor out a 5. Now I'll look for things to simplify, and I can actually simplify this again, make this a 1, this a -1. It really doesn't matter which one you divide by the -1. Either way, you get the same answer. So then if I multiply these two, I end up with -4x in the top over 5, or I can put just the negative sign out front. Next one.
Miss Corey, what did you do in the first step?
2 trinomials. So I got to factor each. So here, factors of 4, I'm going to do 4 and 1. And factors of x squared, x and x. And then because it's a negative, I need 1 positive, 1 negative. So if I were to have reversed it and put the plus sign first, by foiling it, I would have caught my mistake, and then I would have known to switch it. So it matters where you put that addition and subtraction sign. Then for the denominator, again, guess and test, a 2x here, an x here, and then the factors of -4 will be -4, +1. Again, FOIL it. If it doesn't go back, switch your signs. Or even switch your factors. Maybe it should have been 2 and 2. But this is the one that works. Simplify. Again, these look the same, but this one becomes -1, +1. And now rewrite the 1 plus x, rewrite the 2x plus 1, and put that -1 out front. Last example, we're going to do difference of 2 squares and factor by grouping. So the numerator is the difference of 2 squares, so it factors into x plus 1, x minus 1. And the denominator, I'm going to factor it by grouping. Let me rewrite it down here because it's going to get a little long. So group here, group here. GCF of first group is x squared. GCF of second group is 9. Notice this is in common, so you write that once, and then put these two together. Now look for things to simplify, become 1s, and now you're left with just x minus 1 over x squared plus 9. And you're done. And that is it for simplifying rational expressions.